Okay. So there's something I'm going to say, and I'm going to say a lot. All right. And there's a reason I'm going to say this. Science is a language. It may sound like English, but it's not. And like all things, when you start a language you don't know, it's hard work. It is. And that's the nature of doing something new. It's hard work. It doesn't mean it's tough. It doesn't mean it's a difficult subject. It means you just need to practice it. And I'm saying this because I spend a lot of time with year 7, 8, and 9, and even year 10, really reiterating, really repeating this because people actually think physics is hard. It's one of the easiest subjects. And the problem is you've just got to learn the language. And what I'm going to start with, and I always start with this, with year 7s, is energy. The reason is that energy is not an easy topic. People think they understand the words when I'm talking about energy. They think they understand what energy is. They don't. And they'll talk about it in English, in a language that they feel very comfortable with. And they think what they're talking about. And I'm not just talking about students, I'm talking about adults. And everything they're saying is absolutely wrong. It sounds right, but it's wrong. Okay? So the entire point of the next term is for you to get used to the language that I'm using. Okay? And let's start. The most important thing that I'm going to start on in here, and before I go through energy, and I'm going to write a few things down. The most important thing to understand about physics is all about ratios and proportion. Okay. It's all about ratios and proportion and nothing else. And one of the most important things for me, and I was very lucky, I went to primary school in the 70s and in the 1970s, is that when I talk about ratios and proportions, the ideas in my head are based on fractions. Okay. And there's a problem with this. There's a problem with year 7 and year 8 and year 9 with this idea. Not your fault. Absolutely not your fault. And I'm going to put the weight of this on primary schools and primary school teachers. And it's not their fault. But there is a problem there. The problem is that there are some, but not many people in primary schools who are mathematicians and scientists in the first instance, meaning that's not what their passion was, that's not what they studied. And because of that, in primary schools, we tend not to spend too much time on fractions. We spend a bit more, but not enough. And I don't mean being able to work with fractions, I mean being able to understand fractions. And that's, again, really weird for me to say to you guys. And we're going to work on this and we're going to think about it. And I don't mean today, I mean over the next year. And this is the hard part. The hard part is really understanding what fractions are. The physics part of it's easy. All right. Now, my wife thinks I'm a little bit of a annoying nerd sometimes, and I'm quite proud of being part of the nerd herd. To really get to grasp with physics, you've got to understand units, and units are amazing. Units are brilliant, brilliant. All right. And I'm not going to do a lesson on units because the lesson on units is a maths topic, and I'm not going to spend time on that because we don't have much time. And I'm just going to talk to you about it. Units are brilliant and ridiculously important. Okay. Now, distance. I'm going to go through a few basic units. Distance in physics is always meters. Always. I don't care about miles, kilometers, anything. I don't. I don't care about centimeters or millimeters. When we work in physics, we will always work in meters. We might not give you it in meters, but we always work in meters. Time is always in seconds. I don't work in minutes, I don't work in hours. If I'm given information in minutes and hours, I will change to seconds. Okay. Speed or velocity, and I'm not going to look at the words today, and this is what I mean, these are very specific, is always meters per second. It's not miles per hour, it's not kilometers per second, it is meters per second. But today we're going to have a look at energy. The unit for energy is always joules. Oh, do you know what? I might put another one up in there. A mass is always kilograms. Force is always newtons. And you're going to learn this. But we're not working on any of them today. We're really not. We're all going to think about energy. And today's lesson is on energy. The unit of energy is always joules. It's every single time it's joules. Someone says something else, they're wrong. It is joules. Then as a scientist, it is joules, joules, joules. Okay. Now, and again, we're not really going to do much on that. It's just something I'm going to talk about today. My focus today is energy, and the unit of energy is joules. And we're going to see how everything links together, but not today. Today, we're just learning the basics of energy. Now, what is energy? And this is a really interesting one. So I'm gonna have a look at I'm jumping back to our chat. Can anyone tell me? And you're going to be wrong, right? So don't worry about being wrong. You're going to be wrong. There's nothing. Absolutely, I like it when you try and get things wrong. I love it. It's how you learn. All right. But if I ask an adult, right, do you know what energy is? Nearly every single adult will say yes to me, and nearly every single adult will be wrong. All right. So we'll try it, and please, I am more bothered that you try than you get something right. Okay, you're rarely going to get things right the first time unless I tell you what they are, and that's not fun. I want to know what you think. All right. Now, anyone tell me, what do you think? What do you think energy is? You type it in. Type it into the chat box. I have no idea. It might be outside, might be inside. I had it somewhere. Might be in the bathroom when I went there. You can send a kid with a glass of water, please. Light is a type of energy, saying I've been right, but what is energy? All right. Light is a type of energy. Interesting, Sharon. What do you mean by that? All right. Because that's easy to say. And actually, I'll have a lot of year 10 say that to me. All right? And I really. But what do you mean by that? All right. Can you tell somebody your same age what that means? What does it mean? Is there an easy way of saying that? Do you actually know what that means? Right. Anybody else want to have a go? All right. So for me, there's a problem with this question. Nobody can give me a good answer. I'm not talking about you guys. I'm not talking about you. In science, there isn't a good answer for this. There isn't an answer that I will turn around and say, do you know what? I'd really like that answer. I can't give you really a good answer for it. I really can't. Nobody can. And that's why I said I don't care if you're wrong. I don't care if you're right. To be honest, it's just a very, very tough question. As much as Sharon's answer looks really good, it's really hard to explain. Taking Sharon's answer, the best possible explanation we can give you is the ability to do something, to do work. That's it. And even that's not very good. So therein lies the first problem. It is really hard to describe what energy is. All right, it's got to be very personal. It's got to be personal to you, and that's what we're going to develop over the next few weeks. And what do I mean by the ability to do work? For me, it's the ability to either heat something up, or bend something, or squish something, or move something, or break something, or make something. Oh, thank you. Oh no, is that fire juice?
Yep.
Well, year 7 have never seen me drink fire juice before. I mean,
You go in one go then. You burn your
they've never seen me drink fire. The last year's year 7 and now year 8, they've seen me drink fire juice. All right, so I drink very healthy stuff for vitamins. This is fire juice. My wife makes it. She grows the things, and I drink it. And it is called fire juice for a reason. That's not. Oh my god, it's bad. Wow, that's wrong. All right, ginger, garlic, cayenne pepper. Whew. Okay, wow. Right, so the ability to do work. That's all we can say. For to me, in my head, energy is the ability to squish something, to make electrons move. You don't know that yet. To bend something, to heat something up. Okay? All right. So, coming back to what we're going to do today. And I really like both Sharon's answer and Zainab's. Zainab's is slightly different. So let's have a look. There are different types of energy, and we call them energy stores, right? How is energy in that format? How is it stored in that object? There's different ways. Now, I'm going to go through each one, and they are really hard to remember. So I use something like this. Most kids hate learning GCSE energy names, right? And this is how I remember them. My memory is not brilliant, okay? So this is magnetic. So when you get when you get magnets, let me just type that correctly, darlings. When you have magnets, right, they will push and pull each other, they'll attract each other. So you got magnetic, you have this other term here, K. K stands for kinetic. Okay? And that simply means movement. All of my typing is terrible. This is movement energy. Okay? Let's just stretch this out a bit. If something is moving, it has energy. We know that. So when your little brother, sister, or cousin crashes you in with their little stroller, their movement energy has energy, it imparts a force on you, feel it. H stands for heat. L is for Zainab's light. G is for gravity. All right? Gravity. We actually call it, now this is where you got to get used to language, gravitational potential energy. It means if you hold something high up, when you let go of it, it will fall. It has the potential to fall. Doesn't mean it's falling. It just means it's off the ground. Something can fall. That's called gravitational potential energy. C is chemical. Now you've got to be very careful with chemical. There are things that fall into the domain of chemical. One is food, that's chemical energy. Fuel, things you burn, like petrol, and batteries. Batteries contain chemicals. Okay. Now, S is sound. E is elastic. No, let's go for electrical. Electrical or electrostatic. Electrostatic. Da, 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 da. This is elastic. That is when you take a rubber band and stretch it. And is nuclear. Nuclear energy. Okay, and you've got to learn these. I don't expect you to learn them straight away. I expect it to take time, but I also expect you to get it. If I ever, or anybody ever asks you, what kind of energy store does a car take? You cannot say petrol. It has to be one of these words. So a car would take chemical energy. What kind of energy do you have in the morning? Not food. Food is a type of... food contains chemical energy. All right. So then you've got a set of pictures. And these are energy stores. This is a battery. This is chemical energy. This is a car and it's moving. This is kinetic. Heat. I'll change my definition of this. This is somebody holding a ball off the ground. This is gravitational potential energy. Elastic, nuclear, magnetic. My handwriting's disgusting. And this, when you have positive and negative charges, this is electrical energy. It contains electrostatic forces. Right? And this is what I mean. This is a language, you've got to get used to it. On the right, there are some definitions. Okay. Chemical, the energy stored in the bonds of substances. All right. Such as battery, food, fuel, or even muscles. Kinetic, movement. Gravitational, When you're holding something above the ground, elastic potential. When you pull an elastic band. If you see this image as an atom, we're going to be looking at that in chemistry in more detail. If you see an atom, nuclear energy is in the center. Magnetic, there you go. When you put magnets next to each other and they attract or repel. We looked at electrostatic. The one I want to have a look at is heat. There's a different name for it. The internal store. We can also call it the thermal store. Right? It is the total kinetic, that's movement, and potential energy of the particles that make up a system. Right? And you got to learn these, and that's really horrible. That's how we start. Okay? So the first worksheet is everything to do with these two. Your job is to try to write it in your own words, and that's tough. All right? Your second sheet is to think about which energy store we are talking about here. Oh my God, I've talked for 15 minutes. That's too much.